Yep. We're now in Unit 2. So, on the periodic table, and Unit 2 is about periodic table, periodic properties, mostly. There's some other things too. But at the top of each box on the periodic table is a number. And that number is the atomic number. That's what we call the atomic number. The atomic number tells you, the number of protons the atom's nucleus. Now there are two kinds of major particles, if you will, in the nucleus, and that's protons and neutrons. Okay? But it's the protons that identify what kind of element we have. So protons are important because protons tell us what kind of element we have. Okay? All right. Nitrogen, for example. Every nitrogen atom has only 7 protons. Okay? If it doesn't have 7 protons, it's not a nitrogen. All right? So it's identification number. Okay? Kind of like your Social Security number. Nobody has a Social Security number like yours unless somebody's stolen your identity. Right? Well, you can't steal the identity of a nitrogen because the nitrogen's always 7. All right? Now, nitrogen atoms can have different mass numbers, and the number at the bottom down here is the average atomic mass. But they can't have a different atomic number. Okay? You have to have a number 7 and 7 neutrons, 7 protons if you're going to have the element nitrogen. Okay? All right. So the next thing on there is the element symbol. And every element has a different symbol. The first letter must be capitalized. And if there's a second letter, it must be lowercase. Now this is a bit problematic for some people. Some people write their capital letters just like their lowercase letters. Well, that's true. But you need to get in the habit of writing uppercase letters and lowercase letters consistently in chemistry classes. Okay? Everybody got this so far? The notes I have so far? Because I'm going to show you an example here about symbols. Alright, so if I have zinc, there's a capital Z and a lowercase z. Okay? Yes. So this is, I'm sorry, lowercase n, you're right. This is correct. Okay? This is not correct, because that's a capital N. Okay? It's also very important that you have the size of the letters clearly different. There are students who are really just don't make the sizes different. I can't tell what they're trying to write. So here is bromine. And I have students that will write bromine like that. That's okay, that's not. And absolutely, this is not. And this is not. Okay? This is what you get on a winter day when you're cold. You forgot your jacket. Okay? This is bromine. Alright? Now, that video I showed you the other day about element number 115, y'all remember that? Okay. That kind of fits right in here. And when we have an element that hasn't been officially named, it actually has 3 letters. Okay? We're not going to worry about those in here. But if it, just so you know, just to let you know, in that case, the third letter is also lowercase. Okay? Remember it was U, UUP? Yeah. Right. All right, back to our box. Not all periodic tables have this next thing, but the one that we're going to use in here does, and that's what comes under there then is the name. The name of the element. Huh? Yep. Name of the element. Element names are not proper nouns. The only time that you capitalize them when they are the first word in a sentence. Actually, I do have an explanation for the wavy lines, but it would get awfully complex. Well, when I was showing the periodic table outline a while ago, the lines were waving initially. See how they kind of wave a little bit? It has to do with the number of dots per inch, basically, or the number of scan lines on the page and how it fits with the overhead projector. Not enough of an explanation because it really gets kind of complex.
How do you just like figure that out? Like we're...
No, I used to work in television. So stuff like yeah.
I don't see how the
Have you ever watched an old TV show or movie about westerns, and you notice that the wagon wheels seem to go backwards? Wait a minute. Where are we going that? What's the? Why are you getting off top? Anyway, the thing is, when things don't match up, they look weird. Okay, and so film, those old movies and stuff are on film, and when the film frames don't match the frames per second on the, well, actually that's not even true. Where the wheel position is different than where it appears to be on the film frame because the film frame may be taking it at different places. And so, as long as the wagon wheel is turning slowly, it looks like it's turning slowly on the film. But the film frames pick it up at a specific place, and after a while, it's like it's going backwards because the frame's catching it in just the right place to make it look like it's going backwards.
You know when you're driving down the road and you look at a car next to you and like the rims, like it's all looks like they're going backwards. Yeah, they like go forward and then like slow motion go backwards.
All right. Yep. Yep. All right. Everybody got that? Name of the element. All right. Now let's look at what's at the very bottom down here. So now we're going to have a series of numbers. All right. Well, there is no such number like that, but we're going to talk about what that number is. So this number is the average atomic mass. So if you have an average atomic mass, it must mean that some atoms of that element have different masses. Okay? If they all had exactly the same mass, we wouldn't need an average atomic mass. That's right. The reason it's average atomic mass is not all atoms of the same element. Remember, it's the protons that identify what the element is, right? So the protons are the same, but not all atoms are the same element. Same number of neutrons. Two elements. I'm sorry, let's say two atoms of the same element. Two atoms of the same element with different numbers of neutrons are called isotopes of each other. Isotopes. So I thought you were waiting for something new. Huh? I was talking to Shaq over there. He said he was laying his head down a while ago because he was waiting for something new. Well, we're on something new now. Okay? All right, now. Since different isotopes of the same element must have the same number of protons, different number of neutrons is what gives them different masses.